Hello, welcome back to the LOOC. This is Ben Geisler coming at you for another episode of uh, the shooter. We're going to be looking today at adding animations to the shooter, adding enemies that can spawn, being able to destroy those enemies as well. So we've got quite a bit of ground to cover, so I'll just go ahead and get started. First off, last time, here's where we were at. We were basically able to get the game to have the ship move around on the screen. So I'm just going to go ahead and go up to debug and hit run, and I can see my ship moving around on the screen. What we really want is we want this to animate, so we want it to look like it's actually moving across the screen instead of playing as one image. I'm on a very bad computer right now with a crappy frame rate. My downstairs computer is being monopolized at the moment, so I can't use that, so I'm using my poor old one from quite a while ago. But in any case, you can see that it's playing no animations. It's essentially just moving this ship across the screen as we go. What we want to have happen is we want it to look like it's kind of fluttering in the wind. The sails are kind of fluttering in the wind, as well as the smoke is coming out of the backside here and that kind of thing. And the artists of the shooter project from Microsoft have provided us with animations to do so. These are the animations they gave us. This is a full sprite-based animation with 8 different images showing the ship moving, and they're all just slight differences. That is how things are made, basically inside of 2D games. If you take a look at any given 2D game, say for example Castle Crashers, you can see that the characters are moving and jumping. All of these are just simple little sprite animations, and they're moving across the screen. So when they swipe their sword, for example, that plays an animation of them swiping a sword. When this finger that just came up points, that's playing a sprite-based animation showing the finger point. And when the boss runs away with the princess, it's showing an actual run cycle of the boss running. That's probably the easiest sort of way to see it. See, there's that run cycle he's playing as he goes throughout. And there he goes. So we need to be able to do the same thing for our ship. We want it to actually look like it's animating. So what we need to do is we need to be able to basically say, okay, this image from the boundary of this all the way over here is going to be played first, and then this image is going to be played, and then this one, so that, I don't know if I can simulate it here, but basically it would look like this. Would play that image, that image, that image. You can see the smoke is kind of coming out gradually there. That image, and then the final image. Also interesting to note, what Microsoft gave us is these are, if you go in GIMP for example, you can see that this is an image of size 124 by about 69, or 124 by about 70, actually 69 it looks like. It's nice that they gave us up 124. That's kind of a standard size for sprite images, and with there being 8 of these, we'll end up going all the way up to 920 for the size of this image. So that is what we need to accomplish. So we're going to add a new file, animation. And our animation file is going to be the one that plays these animations in quick succession. So I'm going to go ahead and go up here to shooter. I'm going to hit Control-Alt-C. I mean Shift-Alt-C is what I actually meant. And that should create a new file for us. It's thinking here. Okay, here's our new file. So we've got class file up at the top. That's what we want, except we want to call it animation. So we add that to our project. We see animations show up. First thing we want to do is at the very top of the file, we want to add a bunch of stuff so that we can actually do the animation. And I'm going to kind of organize this as such. That should be good. Next thing I want to do is add a bunch of instance variables to this class. These are all the instance variables that are going to be needed. So we start with the sprite strip, for example, which is a texture 2D collection of images for the animation. Then we do the scale. That's going to display the sprite strip, the elapsed time, because basically we're going to want to update every frame. And this is going to tell us the last time that was actually updated. And then this is the frame time for us to display the frame until we go on to the next one. This is the number of frames that are in the animation. This is the current frame we're displaying, the color that we're displaying, the new rectangle that we're going to create for the image strip itself, and the frame width and frame height, as well as if it's active or not and if it's looping or not. So we're going to go ahead and make an initialize function, an update function, and a draw function. Remember, the draw function is just like in Shooter. That's the one that's responsible for actually drawing the content. Important to note here that we're populating a local copy of the data. So we've got this dot color here, frame width, frame height, frame count. This means that any animation in your game can have these following attributes. You can have an animation for basically anything you want, and then it'll always keep track of the color, the frame width, the frame count, the frame height based on this. So this animation.cs file is going to allow us to put other animations on other files. So we're basically making a general purpose animation framework here. Next we need to fill an update. An update is going to look like the following. Oops. Gonna do some code purification there to fix this. And that's how it should look. Basically, we've now copied this in. So first off, we don't want to update the game if we're not active, so don't bother even updating it if it's not, the animation is not currently active, and just return. But we still do want to keep calling updates. So as soon as this becomes active, it's going to go in here. We're going to keep track of the elapsed time, keeping it from game.elapsed time total milliseconds. And if any time is larger than the frame time, we need to switch frames. So at this point in time, if elapsed time is greater than frame time, we move on to the next frame. If the current frame is equal to the frame count, then we reset the current frame to 0. And if we're not looping, then we just set the active flag to false so that it doesn't come in here next time. We're going to grab the correct frame from the image strip, and we do this by multiplying the current frame index by the frame width. So the rectangle that we're going to get from that is going to be the current frame times frame width, 0, and then frame width, frame height. So it's going to, current frame is going to be either 0 or 1 or 2 all the way up to 7, and therefore we multiply that by the frame width, and that's our frame. And now we're going to basically say that we're going to grab the correct frame in the image strip and we multiply the current frame index by the frame width. So we have destination rect equals, sorry about that, we have destination rect equals new rectangle position x minus frame width times scale divided by 2, and the following are, that's the y position, the ending position for the x, and the ending position for the y. Next we're going to draw it. Drawing it is simple now that we have these coordinates, so it's going to look something like the following. If we have it active, then we're going to draw it. Remember our sprite batch draw call from before. We're going to just draw the sprite strip at that destination rect to the source rect using that color. So draw has one of its methods on draw, takes a destination rectangle as well as a source rectangle and a color. And what this does is it adds that sprite to batch for rendering using that texture, the source renderer, and the color. The texture, remember, is the sprite strip, which has been defined up above here, right here, and that was initialized here coming in. So we're going to need to initialize this yet to pass in the texture, to pass in the right position, basically from the player. And inside the player has to be the thing that actually has this animation, right? So the player is responsible for actually playing this animation. So we're going to add player animation called animation here, and that will be what we actually have to populate. We also have some old texture data inside of the initialize that updates player texture. We're going to want to replace this function with something like the following, where we basically say player animation equals animation, and then we say position equals position, set active to true, and set health to 100. We also need to fix the height and width functions because these are returning player texture.width, but we also actually want them to return player animation.framewidth and player animation.frameheight because that's going to be our new heights. Okay, so only left are update and draw. So we want to replace draw with this new thing that basically just says player animation.draw, because remember, player animation draw is going to draw the correct sprite from that sprite strip onto the screen. So we call player animation.draw and parse, or basically pass off the responsibility of drawing the ship to the player animation file. We also want to update the player animation's position. So we say player animation.position equals position, and then we call update on, because basically this has to pass down into player animation so it knows how to play the correct animation. So charting through all this basically at the player level, when we get into update, it's going to have a new position, and it wants to basically send that in to the player animation, and we also have an update. So now the old texture is no longer present in here. This old player texture can actually be removed. And there's nothing else, there shouldn't be anything else that depends on that. We're just now depending on player animation. Next, we've got to do some changes in game.cs to load those. So to load those, I'm going to go into the load content function and replace it with the following. So here we have player animation equals new animation. That's going to be created there. We're going to load the player texture ship animation. We're going to initialize the player animation with that texture. We're going to zero out the vector and give it a position for that animation. And then we're going to create basically a new player position here like we did before. And then we're going to pass in player animation to the initialize. So next we do need to pass timing information in the update function. Let's see, where's my update function? Here it is. At the very top of this, I want to call player.update game time, because that's the game time that was passed into update player, and that should be it. So in summary, we've added a whole new class animation, which is basically for arbitrary sprite strip animations. So you could actually use this on your projects. And this initializes giving those textures. It updates when elapsed time is greater than the frame time. Then we switch and we draw the correct sprite strip. Changes to player involved basically making sure that animation.draw is called instead of the old texture draw update, and that we set the player animation up correctly. And then inside of game1.cs, we have it now loading the new player animation. And you can see the frame count equaling 8, Frame time is actually being set here to 69, so for 69 ticks basically it's going to play a different animation. Oops, one thing I forgot, accidentally I got rid of the sprite batch in initialize rather than load content. I need to add this back and then run it. So there we go, we've got an animating ship. Pretty cool. Next time we're going to look at adding enemies and drawing the background. Probably first up is drawing the background. See you in the next video.